Good morning and welcome to this presentation of Demystifying Heat Pumps Part 2 by the Lighting Design Lab. We're going to give it a minute or so to see if a few more people can show up, and then we will get the presentation started. All right. So again, today we will have Jonathan Moscatello from Daikin presenting on demystifying heat pumps. And there are just a few housekeeping things need to remind you of, and then we can get the presentation started. Advance, please.
Oh, should do it.
There we go. All right. So as a reminder, all attendees are on mute, so you can't be heard in this presentation. There is on your dashboard a way to type in questions. I will be monitoring those and getting those into the presentation at appropriate times. Also, this webinar is recorded, will be placed on the Lighting Design website in the future, and so you can see it again if you want to. And after the seminar, there is a brief questionnaire. We'd appreciate your taking that. Eric Strandberg from the Lighting Design Lab will introduce Jonathan and go through a few other things, and we'll get the presentation going.
Thanks, Robert, and thanks, Jonathan, for being here. Again, it was great last time, and looking forward to another presentation, this time maybe with some Q&A baked in. So Jonathan is with Daikin and Utility Relations Manager, and he's been very generous to share his knowledge today. And so yeah, you know, and it says there, I love inverter heat pumps, but you know, I think we all do. So which is why we're here. But there were a couple of questions. Yeah, there were a couple of questions left over from last time, which you thought we wanted to address. So one of them was, you know, what is the cost of heat pump and installations? Sort of a price range.
This is something I think you'll see a theme of in today's presentation, is that the price range is enormous, and part of that has to do with the fact that there are so many different ways to install a heat pump in a house. Each of those different ways comes in different capacities. So think of it like buying shoes. There's a million different choices of shoes you could buy, and then they all come in different sizes, and you have to figure out what's available to you and make sure it's the right size to fit. So it can be extraordinary. So I would say on the low side, I don't see anyone really able to install a heat pump, a significant modern inverter heat pump, for less than $3,500, $4,000, and that is becoming more and more rare as time, you know, as the inflationary experience that we've all had over the last year, you know, taking that into account. That could be like the most simple installation, but you know, it could be. I've heard of prices for like conversion of air to water systems in the $40,000 and $50,000 range. Where one might fall between that is just really it's really difficult to say.
Yeah. Okay. That's fair. So you know, we talk about traditional heat pumps, and then now we have the modern variable speed heat pumps. So the useful life, you know, how would they compare?
Yeah. The HVAC industry does a pretty good job of tracking averages, though those averages are influenced by like all sorts of installation quality work, and then of course location. So for instance, if a heat pump was located on a coastal area near a beach, it just doesn't last as long due to salt degradation and so forth. But I think the think of the modern variable capacity heat pump. The really good models are made by companies that have a quality tradition that's like Toyota, Honda, and all of the Japanese car manufacturers that have just an extraordinary like reliability and useful life. And that's, at least for some of the Japanese made products, that same expectation of consumer like reliability and longevity is there. One of the manufacturers I worked for, like, they don't like to talk about this, but they say they design their products for a 20-year useful life. I heard that as sort of a back kind of room to coffee, water cooler kind of discussion. And I think that that's possible. Also, it can be possible for a traditional heat pump, like if it's installed right, if it's maintained and cared for through its useful life. So I think one can expect a pretty good useful life from these machines, and I think 10 years would be in the Northwest, probably on the low end. 20 years would be a great outcome, and I think we can expect something in between those two.
Okay. Yeah, great. That's good to know. And then finally, for leftover from last time, geothermal heat pumps.
Hmm.
You know, ground source. How often are they seen in Washington State or even the Northwest?
Yeah, not as much as other parts of the country, and that has more to do with the fact that even over in eastern Washington, the winter temperatures are not as cold. So if we were just to talk about like the I-5 corridor in Washington and Oregon, it's very rare to see a geothermal heat pump, simply because the cost of that geothermal installation with the underground portion of it is just really much higher. And because we're not as cold, we have the air source, or the heat pumps I'm going to talk about today, are available to consumers. And we're in such a great operating range for the products I'm here to talk about today. It makes the additional expense of a geothermal heat pump really just hard to justify. Now, people are putting them in because like they're interested in the technology and some of the benefits, but again, they're just so much more rare than other parts of the country, which, experience that extraordinary degree of coldness. However, even today, the newer versions of the products I'm here to talk about today are becoming as useful and again, that same cost, as useful in these very cold climates, and that same cost benefit kind of analysis can be done. And so I think geothermal has a place, but I think it's going to be used even less in the years ahead.
Okay. Well, great. Thanks for touching on those holdover questions.
Yeah, no, thank you. Happy to regroup from those good questions. Well, in this presentation today, we're going to talk about how to design a heat pump installation with a specific emphasis on delivering both the energy savings that utility programs want and need, but then the additional things that homeowners want, like really good comfort and low cost of operation. So that's going to be our particular sort of theme and emphasis, is energy savings and comfort, and how to do it, design for it properly and install for it properly. Now, this little thing I'm going to do as I work through the content today is talk about how heating and cooling system design is done today, and use that as a way to highlight the differences on how you design for a heat pump. And then we'll look at, how that specific design might differ when you apply it to a modern variable capacity heat pump. And finally, I'll just illustrate some practical aspects. I call them tips and fails. And it'll kind of bring some of the concepts I might discuss earlier in the presentation today into some real world practicality for people to think about. So with that being said, let's dive into it. So how is heating and cooling designed today? So for most contractors today and the homeowners they serve, historically we've been installing fossil fuel furnaces, mostly natural gas, and then usually an air conditioner for cooling. That's sort of the typical way to do that. And, you know, because of that typical kind of equipment arrangement or package, like design is done in a pretty consistent way. And that involves putting in a furnace that can do enough heating for the coldest days of the year. And then having some additional excess capacity in that furnace to allow for the homeowner to like quickly recover the temperature of the home after they've left for vacation or left for the day, or possibly some people like to sleep with it quite a bit colder at night. And in the morning, you want the house to recover back up to comfort pretty quickly. And to accomplish this quick recovery, you need that excess capacity in the system. So typically heating and air conditioning contractors have this excess capacity built into their designs. Now, for a modern variable capacity heat pump, we don't do that because it becomes much more expensive to do that. And I'll explain why in a minute. It's not expensive to design with excess capacity for a furnace. So for example, if we had a 60 or 80,000 BTU furnace like you'd see on the left, the cost is only $83 to go up to the next highest capacity, and then $120 to go up to the next highest capacity, and then $100 to go up to like 120,000 BTU furnace, which is an enormously powerful furnace. These are the difference that the contractor buys this for, by the way. Probably the homeowner's cost would be different because it might include the installation requirements that might be different from size to size. But from the cost of good, that's really a very little additional cost for the homeowner to have a excess capacity in their heat pump. And so another thing about this oversizing that I'm talking about, or excess capacity, is that in the Northwest in particular, modern houses that are being built can actually have a greater cooling need than the furnace itself. And so there's this thing that happens for people like me who used to design heating systems for homes, where we need a larger capacity air conditioner than the furnace, believe it or not. But because the airflow requirements of that air conditioner require a larger air volume, you have to put in one of these large capacity furnaces because it just can move much more air. And it's a little complicated, but the airflow characteristic or specification, they're linked to each other between the outdoor unit's requirements and that furnace's capabilities. And so, for example, in the Portland metro area where I live, I often had to sell 100,000 BTU furnaces because it could move enough air for the 36,000 BTU air conditioner I needed to install. And so that heating and load of that house might only be 30,000 BTUs, but I had to install a 100,000 BTU furnace. It's really unfortunate, but there was really no way around it. And so this leaves many homeowners this scenario, and this, I think you get the gist of it. There's just a lot more heating capacity from furnaces and houses than they need. And heating contractors have been pretty conditioned by the tradition to have excess heating capacity in structures. And so what people in my role at the manufacturer or distributor have to do to support contractors is teach them a very different design strategy for variable capacity heat pumps. We need to get them to right size, is the term, or make sure that we size the heat pump for not to have this excess capacity. If they did try to put in like 100,000 BTUs of heat pump for a heating load on the house that might only be 30 or 40,000, it would just be incredibly expensive. We'd have to put multiple heat pump systems typically in to do that, and it would be both unnecessary and very expensive. Second part of this is, with a modern variable capacity heat pump, as we mentioned last time, we don't advise setbacks more than a few degrees for comfort. Like, you don't set your thermostat back at night more than a couple degrees. or when you leave the home when it's unoccupied during the workday. You don't set it back more than a couple degrees. As we've learned, it takes more energy and cost to recover the house than it would to maintain it over the unoccupied period. Now, if you go away on vacation, absolutely you set it back for like a week or something like that, or days on end. Yes, you'd set it back. But for just normal occupancy over the 24-hour period, we don't use setbacks. So with all of this in mind, I want to talk with you today about the 4-step heat pump design process. It is something I've used in homes when I was selling, other people I've talked to, and I've trained hundreds of contractors over the years to use this, and it works reliably. It mirrors the professional organization for heating and cooling contractors. It mirrors their process as well. So I'm by all means conforming to like a common and accepted practice here. And it goes something like this. Step 1, always perform a load calculation. And this is the only way we can remove guesswork from the process of selecting equipment. As I mentioned before, a contractor typically goes into a home in the Northwest and sees an 80 or a 100, possibly a 120,000 BTU furnace. But when you do the load calc, you'll quickly discover that the heating requirement of the home on the coldest, reasonably coldest design day of the year is 30, 40,000, 50, something like that, maybe 60. And so, right, we don't have these enormous, we don't need these enormous heating systems. We need something that's much more modest. And we just never know until you do the calculations. And so that's why we always start with a load calculation. The second step in the design process is to evaluate the ductwork. So if your heat pump design relies on reusing the existing ductwork in the home, you have to evaluate that ductwork for suitability for a heat pump. And the reason for that is we have to make sure that the system air requirement of the heat pump can be met. Now, in some older homes, my house was this way, the original ductwork was undersized for the requirement of modern heat pumps. That's because originally my house, when it was built in the early 1900s, had something like a coal burning system, which used very low airflow, but that's very, very hot air. And heat pumps use more air, but the air is not as hot as an oil furnace. So an oil furnaces are renowned for having 140, 160 degree discharge air. I mean, it's extraordinarily hot. Natural gas furnaces about 130. The modern variable capacity heat pumps are about 120. Now my grandpa's heat pump, they could be down in like the 100 or 90 or even 85 degree range. So you want to be in the 110, 120 degree range for comfort, but to heat a house, you just need more air at that modest temperature. And you have to have ductwork that can do it. And so first we do the load calc to understand how many BTUs. Then from that we can understand, okay, I need so many cubic feet of air per minute of air. We have to see if the ductwork can handle that without being noisy or just overly restrictive. And once you evaluate that, then you can start selecting the capability of that ductwork. You can then start selecting the equipment. But before we do that, because we care about energy, we want to look to the building envelope itself and look for some easy wins, some simple ways that we could possibly even lower the heating requirement further. There's 2 reasons for doing that. Number 1 is if we can save the customer from investing in heat pumps that can produce, let's say, 40,000 BTUs of heat, and instead install heat pumps that can produce 32,000 BTUs of heat, we will save them money just in the cost of acquiring and installing the equipment. So that's a smart business strategy. Secondly, in terms of comfort and energy savings, it will improve the home and the experience for the homeowner too. So we're simply just going to need smaller, more efficient, less energy intensive equipment operating at a more modest sort of level. So oftentimes homes have really simple, easy ways to drop the heating capacity. It can be doing some air sealing that had been missed in the construction or remodeling. It can be insulating around an attic hatch or an attic door or something like that. We generally, windows in the Northwest, I mean, there's lots of reasons to replace windows on an older home. Generally, the bang for the buck isn't there. Wall insulation, similarly, it's very hard to insulate walls after the fact. The bang for the buck generally isn't there in my experience. I'm talking about blowing in attic insulation if there isn't any or there's very little. That's a very low cost, believe it or not, way to get the incredible bang for the buck, let's say. And then floors in the crawl space. If there's ductwork in an attic or crawl space, that's an easy place to gain some huge savings right off the bat by, sealing some of the joints and insulating the ductwork. And really quickly, you can drop the heating requirement down for very modest sums of money. Basically, you can drop that energy requirement down, and the savings on the equipment and installation can typically pay for this insulation and air sealing. And that's the idea, that overall it's a less expensive installation, which saves a lot of energy. And so that's why we do it. Okay, the final step, once we've done a load calculation, a ductwork evaluation, and looked for some easy wins to drop the heating requirement through air sealing and insulation, the fourth and final step is to select the heat pump, right? We've done actually a lot of work to get to the point where the homeowner is like, how much does this cost? Well, as a contractor, you can't know how much it costs unless you have the heat pump system selected, right? So you can see there's some work and some steps to do before you get to that thing that everybody wants to know, which is how much does this cost? And so let's talk about that. Okay. So the before I move on to selecting the heat pump, I'd say, there's some choices involved. And in lieu of going into this question between a standard APC or
Jonathan,
oh, Robert, yes.
Before you do that, I have several questions similar on the stuff you've covered up to this point. So maybe before we go on, let's do that.
Okay.
Some things about load calculations. How is the load calculation typically performed? Kind of information related to that is provide a link or Excel. So what tool might you recommend, or anything you can say on load calculations?
Yeah, I mean, I think there's really one official way that the contracting industry endorses for doing a load calculation. It's called ACA Manual J. And ACA stands for the Air Conditioning Contractors of America. And so the ACA Manual J is the way to do it. However, the utilities in the Northwest have identified that depending on the kind of heat pump installation you're doing, there are other much more simple and defensible ways to do a load calculation. And so without going into too much, I'm going to cover that in just a couple of minutes in the slides. So you'll see about how to design for the displacement method. And then in terms of software, I have found in the home, you want a software that can do the load calc simply and easily, but then it's nice to be able to see some additional information once you have that load calculation. So RightSoft was my favorite software. It's just very expensive. And so you have to be prepared to invest in software, put it on a device and keep it updated. The utilities in the Northwest identified that the cost of the software was a barrier for contractors, and so they developed something called HVAC sizing tool. And you can go to a website that's hvacsizingtool.com, and it's a free software it's based on ACA Manual J. It's just not accredited, but it's the same calculation method. It's a wonderful software. I love it. I use it. I teach people how to use it. And it doesn't provide all of the additional information that I might want, but it provides the information I talk about here, which is you get the load calculation, and then you can do ductwork evaluation within it. It's a little bit more complicated than I wish, but then it also illustrates the easy wins of where you could get the most bang for your buck on weatherization. And so with that in mind, I just love that that software. Again, HVAC sizing tool. It's free for contractors. It's available at that website.
Okay, couple more real quickly. I think one is, and the second will be a kind of a segue. One is asking about a blower door test. Does that give any valuable information for calculating each heat pump sizing? And my recollection is that might be required by Manual J.
It's not required by Manual J. So there's two
Okay.
factors within the Manual J, and all of the software have like something for the user to set. One has to do with duct leakage and insulation level, which is a huge part of the heat loss or heat gain calculation. The second is the structure's infiltration rates. And the only way to really know those answers is to do a blower door test. Now, I'm not the kind of contractor that is a home performance contractor, meaning I always had about an hour or two to spend in the home with someone to do a heat pump design. And the blower door is a really elaborate building science approach. It's great. I'm not saying anything bad about it. I just never was a part of a business that that's what we offered or did. So what I have learned to do is look for some reasonable best indications about the home to determine ductwork leakage and infiltration rates, those two very important settings within the load calculation software. And I think I make best guesses that are educated on some indicators. I can't, this is a whole subject matter, Robert, to go into. So
Sure,
I'm not going to
no
go
doubt.
into it,
Okay,
but it's
fair
a good
enough.
question.
So the last one here that I'll put in now, and it'll get to your, I think, what you're going to cover next, is what are the considerations for buildings that don't have ductwork? Are there unique considerations for ductless mini split systems? So you're talking about equipment selection. I think that fits right in there.
Yeah, we're going to talk about this because there are in the Northwest, of course, tons of houses, millions in Oregon, Washington, Idaho, and Montana that don't have ductwork today. And it makes no sense to go back in with ductwork when we have this wonderful, probably in my mind, the top technology for these modern heat pumps, which are called ductless heat pumps. And so that's the product to put in. Of course, it's got some specific strategies, and we're going to cover those in the rest of the presentation.
Okay, continue on.
All right, great. So here's what we're going to do. We're going to cover a bunch of tips for selecting an installation design for these modern heat pumps. And I'm going to run through them as fast as I can because I want to get into some of the fails that I saw where people have blown this strategy and missed the boat entirely. Because I think we can learn from mistakes as well as we can learn from recommendations. Okay, so number one is to know your equipment options. Oh my God, there are lots of options. And I can tell you, having all of those options really does stymie a lot of customers, a lot of contractors and their customers. So here's the major types one needs to know about. There are cold climate variable capacity heat pumps. And this type of heat pump is available under a variety of brand names that differ by manufacturer. But they have one thing in common, and it's that they can produce 100% of their rated capacity when it's 5 degrees out, Some manufacturers are now doing 100% of the rated capacity when it's -5. All these heat pumps, just so you know, all heat pumps are rated for their capacity at 47 degrees Fahrenheit. When I say that they're able to produce 100% rated capacity at 5 or whatever, I'm saying that the same number that they can produce at 47, they can continue to produce at 5 degrees Fahrenheit, two hugely different numbers. So if a heat pump can do all of these wonderful technological things that it can do to continue producing heat at 5, the same level at 47, this is amazing, right? This is what we've all been waiting for. These cold climate heat pumps also continue to operate depending on the brand from like 13 degrees Fahrenheit down 15 degrees, sorry, -13 degrees Fahrenheit down to -15, and some brands now are reporting -22 degrees Fahrenheit. This is the gold standard. However, if you don't live in an area that technically falls into that cold climate definition, you might just need a regular variable capacity heat pump. And manufacturers more and more are coming out with these variable capacity heat pumps that are more for like regular winter climates like we experience along the I-5 corridor here in the West. And then really for everywhere in the US that is kind of below about 35 degrees in latitude, so the southern tier of the US down, they just doesn't experience cold climates. And so a lower priced variable capacity heat pump is totally sufficient. So there's those two big options. And for us in the Northwest, we're kind of like, we're far north, but we're very mild. And so it becomes a little bit overwhelming for some people to think, what should I choose? And I think if you follow my design practice, the 4 steps I talked about, you'll have certainty that the heat pump that you choose will work or not. So the other thing that's very amazing about your equipment options is there are multi-zone variable capacity heat pumps. And this is where one heat pump can provide heating and cooling to multiple indoor units. And so back in the days, we had a single furnace and a single central air conditioner trying to uniformly heat or cool the house, running through all this ductwork. And it's very challenging to get those uniform temperatures throughout the house. And so most homes have areas that are underserved by the ductwork because of that. Now we have multi-zone variable capacity heat pumps, which allow the house to be sort of conditioned in parts. And so the hot spots and the cold spots that are typical in many homes just can be, gone away. They can make them go away with a multi-zone heat pump. The final thing to consider is the modern heat pumps have tons of different indoor units that are able to work with them. And so again, it gives so many more design options to the homeowner and their contractor. It can be overwhelming. You need to know your options so you can fix the hot spots and cold spots or work with the unique constraints of your house. But that comes at a price. Like, how do you choose? And I think that this is a big complication for many contractors. And so my recommendation to any contractors, know your options, don't be freaked out, but pick a couple of go-to choices that work and deliver the comfort and the savings that homeowners want. And that's the strategy. So just to give you a hint on these indoor units, like there are indoor units that can replace furnaces and connect to ductwork. There are units that can connect to ductwork, but you can install them in new areas, like in a small part of the home, in an attic or in a closet, and just serve a couple of rooms. There's ductless style indoor units that go high on the wall. There's ductless style units that go low on the wall. There are ductless style units that can be hidden in a closet and serve just that one room. How do you choose? Right? This is the big challenge that people have. You got to first know your options and pick your go-tos to get through that. So that's my tip number 1 on designing a house and a heat pump installation. Tip number 2, try using multiple heat pumps. Now, I mentioned before we don't want to oversize, and I mentioned that most homes have lower heating loads than we think they do, or that the furnace might suggest. So if you're converting that home, instead of putting in like a central 40,000 or 48,000 BTU heat pump, maybe try doing it with two 24,000 BTU heat pumps. At first, it might seem like a more expensive way to achieve the goal of converting a home to a heat pump. In my experience, when contractors really get good at these variable capacity heat pump installations, they learn that there's more material and labor efficiency in trying to do heat pumps, and the cost isn't as great. What homeowners experience is they get two smaller, more energy efficient heat pumps, providing a greater level of comfort in the home than if they were to try to use one large heat pump. So in the end, multiple heat pumps can give you a reasonable cost or comparable cost, but give you better comfort and better energy efficiency. The best example I can give you is two-story homes in America. Anywhere you go, in the summertime, it's hard to get enough cooling to the upstairs unless that upstairs has its own heat pump dedicated to heating and cooling it. Okay, moving right along. Tip number 3 is in a colder heating dominated climate, like we can experience here, and certainly we experience up in the Cascades and in eastern Washington. For the coldest days of the year, instead of trying to get the heat pump to do 100% of the home's heating, if there's an existing heating source in the home, like a gas fireplace, or maybe the house has a gas furnace, it's within its useful life and it's working fine, we design the house for a modern heat pump, but we retain these additional heating sources in the house. And for those few days or maybe 50 hours a year that we are in what we call our colder extreme period, we design the home to use these secondary heating sources. The benefit of this is we need a smaller and possibly more efficient heat pump, which saves the homeowner money and energy. So these secondary heat sources are a wonderful way to convert a house, get the job done, and the really good heating contractors are doing this all the time. Okay, tip number 4, and this is my recommendation to contractors, but if there are any program people on the call too, more and more, I mean, we're basically empty nesters in my house. I have 3 sons, 2 of them are adults and one's in college. They're out of the house, and our youngest is the only one home. And very soon, it's going to be my wife and I in a 4-bedroom house together. And so it's very common. People find themselves in my situation, and they want to stay in their home. They love it. They're not ready to move, but they want a more modern and efficient way to heat and cool their home. And the best way to do this is what I call the empty nester design. And that's where, like, you keep the existing heating system in the home and you put a ductless style system in that master bedroom with one indoor unit, and then perhaps down in the main living area where they spend most of their time, like there's usually a kitchen family room kind of combo downstairs, and the ductless system takes over the majority of the heating and cooling, and the central system that's there is set back 5 to maybe degrees, maybe 10 degrees. You play with that, you teach the homeowner how to find the sweet spot, and the ductless takes over the great majority of the heating and cooling energy needs of the home. It is an incredibly comfortable way to operate a home with much less energy involved. It's a very real business opportunity because there are lots of empty nesters. And so it's something I think we all need to be prepared for. If I was a innovative utility program, by the way, like we have at Seattle City Light, I might explore trying to incentivize just that application. Could be interesting. Now, I'm going to get on to an approach here that is near and dear to my heart. It was pioneered in the Northwest by people that I know and cherish, and it's called the displacement technique. It's very similar to that empty nester kind of approach where you have an existing heating source in the home, and ductless is used to take over the main living area where people spend most of their waking hours in the home. Now, we have a ton of electric resistance heated homes in the Northwest, baseboard or cadet wall heaters. Multifamily is chock-a-block with them. And then, of course, there's lots of over 1 million single-family homes are estimated to be heated this way. And the ductless system, when applied properly, you put it in that main living area, it's designed to take over 100% of the heating requirement of that main living area, which is usually like a kitchen, dining room, family room kind of space. And that system runs to create comfort in that main living zone all heating season. And then the bedrooms or the additional rooms still have their baseboards. The homeowner is taught to turn those on as needed, but to use them as little as possible for their comfort. And it works beautifully, and it saves people tons of money. And it's a very low cost investment in terms of a heat pump. It's just a single zone ductless heat pump, which is, depending on the market, it's a $5,000 to $7,000 investment these days on average. So, okay, that's the displacement technique. Contractors are using that in a variety of ways beyond electric resistance now, and they're using that to displace gas, propane, heating oil, and a whole bunch of stuff. Okay, this is a near and dear to my heart strategy. It's called the undersized ductwork scenario. And it's a little complicated, but let me explain. Let's say we aspire to replace a centrally ducted home. Maybe they have a gas furnace or an oil furnace, whatever it might be. And we do our load calculation, then we do our ductwork evaluation, and it's clear we want to apply like a 42,000 BTU heat pump, but the ductwork's really undersized and it can only do like maybe 36,000 BTUs of airflow, equivalent airflow through the ductwork. Okay, it's not impossible. What you can do, and each of the best manufacturers I know, like Daikin, Mitsubishi, Carrier, Fujitsu, all the main variable capacity heat pumps manufacturers make a heat pump that has a furnace replacement for the central ductwork, and then that same heat pump can put 1 or 2 or so, even more possibly, but I would recommend keep it simple, 1 or 2 like wall-mounted ductless units elsewhere in the home. And so between the, let's say, ductwork heating that the heating that you force through the ductwork and the ones that comes out through the head, you get all of the heating and air conditioning requirement for the house, even though the ductwork presents a limiting factor in the home as you find it. So it's our workaround, if you will. And it's something where contractors who want to do more heat pumps, you really need to be prepared for this, because this is going to happen a lot in older homes. And I've just shared with you the strategy on how you do it. Now, you could also do a single zone to go through the ductwork, and then another single zone heat pump. It's possible. So there's more than a couple ways to get the job done here. But anyway, I've shared a lot. I could share more. I'm going to keep it moving here. If I can get the slide to advance. It's not. There we go. Okay. Now that I shared some tips, now I'm going to share, okay, how do people screw this up out in the field? And I think, again, we can learn as much from our mistakes as we can from the recommendations. So fail number 1 is what I call relying on guesswork. And this is where a contractor, maybe does the job of a load calculation and evaluating the ductwork, but they don't go further and really understand the equipment's capacity at their local design temperature. And I have to confess, manufacturers today are not making it easy enough for contractors to find this critical piece of information, right? Let's say I'm in Bellevue or right in downtown Seattle. My guess is that the winter heating design temperature, so what I need to use in my calculations, is something in the high 20 degrees. Now, if I go out I-90 and get to one of the higher elevation towns, it's really quickly going to drop down into the teens, right? It's a big difference in temperature. And so as a heating contractor, we have to know the heating design of our location. And then we have to know what the capacity of equipment we might want to use is at that temperature of that location. Contractors need to go and look that up. It's in the manufacturer's engineering performance data. Unfortunately, sometimes they just kind of guess based on some simple metrics, and it's not the right way to do it. You cannot rely on guesswork. You have to do some simple math and have that information ready. What we've done, what I've always done for myself when I was selling, is that I had my go-to products that I trusted and liked, right? I narrowed the field of choices down to the equipment I know I liked and trusted, and I had the performance data in a separate little file folder, so I always had it handy to use. And in that way, it wasn't like, you know, a burden to do the right thing. I never had to rely on guesswork because of that. So, okay, relying on guesswork, epic fail. Number two, oh, this is the one that drives me nuts because I see it all the time. There's some pictures on this slide of contractors trying to do so much and making for very complicated designs. And this is where I call it opening Pandora's box. Remember I mentioned that there's a lot of choices that contractors have and homeowners have with this variable capacity equipment, lots of different models, lots of different indoor unit choices. Installers should try to keep it simple, and they should try to help the homeowner understand the implications of choosing something more complicated. Mechanical machines and equipment get installed by tradespeople, and we need to keep all of this mechanical stuff and installation requirement really simple. When it's simple, it works better. And so, unfortunately, what I see too often are contractors and their customers opening Pandora's box and creating these overly complicated set of choices and overly complicated set of installations. That my sort of key motivating question to anyone is, we've learned this lesson in life, I hope, by the time of a certain age, that just because you can do something doesn't mean you should do that thing. And that's a big function of what, unfortunately, we have with these variable capacities, is we have the ability to do this wide variety of things. It just doesn't mean that we should do all of those things. We should focus on simplicity instead. Okay, heating contractors for ages have been what we call central plant thinking. We want a big boiler or a big furnace and a big air conditioner, and we transfer all that heat energy throughout piping and ductwork and stuff. And, you know, in bigger, older homes, the heating loads will be large and you will need to use multiple heat pumps. And so you have to break yourself of this one big central plant thinking as a contractor. And as my experience, homeowners are actually easily convinced to use a couple of small, highly efficient, modern variable capacity heat pumps instead of one big one. And once you break yourself of central plant thinking, it becomes really easy to make simple, labor and material efficient installations that work beautifully. So be quick to, I would say to any contractor, be quick to recognize when 2 or 3 is better than 1, and you'll be served well. Yeah, we talked about this in the beginning. Basically, bigger is better thinking is always a source of trouble when you're dealing with mechanical energy, you know, efficient equipment, because all that energy efficiency is designed for a machine to stay within its comfort zone. And when you oversize it, you kind of take that piece of equipment and it wind up making it start and stop a lot more than it's designed to do. And nothing good comes from that. Comfort is sacrificed, energy efficiency is sacrificed. So bigger is better thinking is really one of the most common fails I see contractors making. And if you trust your load calculation, you do good design work, trust the numbers, and you won't fail. Okay, I made this mistake when I first started selling ductless and being involved with money, with heat pumps. Is I used too many indoor units with my multi-zone designs. I call this the too many heads fail. Um, Basically, as heating contractors and homeowners who have ductwork, we have lots of little grills and registers all over our house to kind of distribute the heating and cooling and to wash the house essentially with warm or cool, clean air. And that's the way you did it with central system and ductwork. And with ductless, you just don't need it. They work much more differently. They're able to move air silently across large spaces. They operate continuously, and as such, they're able to like get the job done with much fewer registers or air discharge things. And so I see this all the time where contractors put 3 and 4 heads into an area with that only needs 1. The customer pays a lot more money than they needed to, and they probably don't have as energy efficient a system, probably. So anyway, that's it for my fails. They are common, easily corrected with a little bit of education. And I hope that after seeing this, you feel like, oh, there's not that much complexity here. There's a set of basic practices to follow and a few pitfalls to watch out for. So, I mean, we're trying to electrify. I hope you feel like after these couple of videos that you feel like you can do this. Modern heat pumps, not that hard. There's just some changes in thinking and practice. Follow the 4-step design process in here. Get some load calculation and ductwork training if you're a contractor. It's really part of, I can't stress it enough. It's going to make you a better contractor. And then, of course, use the tips and fails. And that's all I've got for you today. I think the last slide might have my contact information on it. Feel free to contact me if I can be of any help. Robert, do we have any other questions?
No, there's one I'm going to give you offline, but all the others I think you've covered what we're doing here. So thank you very much.
Okay. Yeah, you bet. Eric, do you have any last thoughts or questions?
No, Jonathan, this has been great. Looking
Actually,
forward
there's
to
one more just came in here.
All right, let's do it.
Do you still need, this is rated the last thing you covered there. So do you still need 1 head wall-mounted unit per bedroom or zones where doors are closed?
So that's a code requirement. Unfortunately, yes. Code requires that any space with like a door must have its own heating requirement, at least in the Northwest. I think in the South, they might even have an air conditioning requirement. We don't have that up in the Northwest. So, they're in the North. So this is where I see contractors installing electric space heaters in sunrooms because it just doesn't make sense to put its own ductless head in a room that might not be used all of the time. But in the rooms that are used all the time, you put the ductless heads. I could tell you more and more customers want air conditioning in their house. And if that's the case, yeah, you're looking at a bedroom, even a small one, having a ductless indoor unit in that bedroom. And, we can do it.
So once you put the first one in the house, you have to make sure every separate doored room has their own?
No, it depends on what the house, like, so for an existing home, it just depends on what's there to begin with. And if you can retain that heating source that's in the bedroom, you would do that. Unless for some reason you put the ductless in the main zone, retain what the house has for the back bedrooms, unless you just are dying to have air conditioning and get rid of baseboards or whatever that room has. So of course, this is all sort of the conditions. Now for new construction, it's a totally different conversation, by the way. The new construction code, the levels of insulation and air sealing are so high that bedrooms need like 1,000 BTUs or less, really, really low heating and cooling thermal requirements. And so for what we do, what we see happening, and I recommend this for the modern variable capacity is the main leaving area gets like a ductless head or one zone. And then we use a small fan unit and some ductwork, and we distribute that one machine's heating and cooling to each of the bedrooms that they're small and they require so little heating and cooling. That's actually better design than to try to put a ductless head in each one of these newly built bedrooms. Again, the heating and cooling requirements are so low, it would be grossly oversized for that bedroom.
Okay, well, thank you very much for insights on this.
Yeah, you bet. Well,
Eric,
pleasure to help.
Anything you want to follow up with?
No, just appreciate it, Jonathan, as always.
Yep, happy to help. Have a great day. Is it raining up in Seattle today?
It's always raining in Seattle.
Well, liquid sunshine. We have it down in Portland too.
Yeah, I think we had a heavy mist this morning, but it's going to dry off. Who knows?
Well, enjoy the rest of your week. Have a great holiday weekend.
Thank you, Jonathan. Thank you all for attending. Hope this was useful to you all. Take care. Bye-bye.